Welcome my dear followers. This is video number 342 and in this model I am going to explain how can we detect outliers in an ideal regression model, and then I'll apply some diagnostic tests. So in order to do that, let me have my data. This is my data in Eviews. This is a quarterly data on GDP, investment, personal consumption expenditure, and government expenditure, and the total number of observations is 129. So let me start with the basic model. Since these variables or these time series are in level, so if I regress this model in the following form, like GDP constant, personal consumption expenditure, investment, and G. Now this is the estimated model. Now all these variables are significant, statistically significant. R squared is also very high, but this is time series data, and this regression is spurious. So instead of running regression at level, I would like to run a different types of regression. So let me use this, that is log of difference in GDP and consumption and constant, and then d log investment, d log personal consumption expenditure, and d log government expenditure. Now if I run this regression, here again all my variables are significant, and these are the coefficients. R squared increased, and Durbin-Watson state is 2.01, so there is no problem of autocollinearity. So let me check the diagnostic test before I try to identify outliers. So let me start with the, so this is Jarka-Bera test, and this probability value is less than 0.05. So this data doesn't follow normality, so it's almost equal to 5%, a little less than 0.05. So in fact this does not follow normality. The second diagnostic test would be serial correlation. This model doesn't have serial correlation. Similarly, if I try to check heteroskedasticity, now this is Bruce-Pagan Godfrey, and now there is problem of heteroskedasticity here. Now I will also check the arch test. There is no problem with the arch, but we saw two main problems with this model, that is the data doesn't follow normality, the residuals doesn't follow normality, and there was problem of heteroskedasticity. And let me check the stability of this model. So I'll click on recursive estimate and then Kushroom test, and after that, okay, this model is almost stable. So there is still some problem with this data. So now let me try to estimate this model in a different way. So again I am following d log GDP constant, d log investment, d log personal consumption expenditure. Sorry, this should be d log rather than d long, and d log government expenditure. Now in order to try if there are any outliers in this data, I'll click on options, and after options I'll go to auto detection, and after that I'll click on options again, and here I would like to click on this because I want to see if there is any shift in this, and then let me also make this 1%. So if I click OK twice, my new model is here. And the difference between this model and the previous model is that in the previous model only there were 3 coefficients and a constant, but now this model has automatically detected and blocked outliers in this model, and these are the various dates. That is December 81, and then there is a June 82, and then this is a September, and then this is December, and so on. These are the various months of the year, various quarters of the various years that have been detected as outliers. So I will check now the diagnostic of this model. So let me start with the, first of all, I would like to start with the histogram. And now, after blocking the outliers, now the Jarka-Barrett test is insignificant. This value is greater than 0.05, so it means that the data, that the residual now follows normality. So this is almost normally distributed. These residuals are almost normally distributed. After that, I'll check the serial correlation LM test of the residuals with leg 2, and these p values of the observed R square and chi-square, these are statistically insignificant. So this shows that there is no problem of serial correlation of these residuals. And after that, let me also check heteroskedasticity of these residuals. So first I would check Bruchpegan, Godfrey, and clicking OK, bring these results, and all these p values are much higher than 0.05. Now, on the basis of these values, we conclude that there is no problem of heteroskedasticity of these residuals. I'll also like to test for arch effects in this residuals. So I'll click on arch, and by clicking OK, again the observed R squared with chi-square statistic, the p value is the associated p value is 0.5409, which is insignificant, and we fail to reject the null hypothesis that these residuals have no arch effects up to Q. After this, let me also check some other diagnostics like correlogram Q statistics up to 36 years legs, and all these value shows that there is no problem of serial correlation. Similarly, if you look at autocorrelation and partial autocorrelation, all these values are within the lower and upper bounds, so there are no problem of autocorrelation, serial autocorrelation. And finally, I want to check the stability of this model. So here I will click on Kusum test. Clicking OK produces this model. Since this model is within the lower and the upper bound, it doesn't go out of these limits, so the model is stable. So one thing can be concluded from this: when we didn't test for outliers in this data set, there were some problems when we used the diagnostic test. That is the residuals were homoscedastic, and they were not normal. But when we instructed Eviews to identify outliers and to block them, then in that case, when we use the diagnostic test, there was no problem of serial correlation, no problem of heteroskedasticity, and the residuals followed normality, and there was no problem of partial autocorrelation and autocorrelation function regarding serial correlation, and the model was stable. So this model is meant for beginners, those students who want to learn econometrics. They should learn these things. Once they estimate the model, first of all they must know whether the model is applicable, whether it is theoretically okay, whether the functional form of the model is okay. If this is time series data, they should check for stationarity. So if this is stationary data, then they should use first difference in regression, and after that they should check all the diagnostic tests like serial correlation, normality, histogram, and heteroskedasticity and stability of the model. I hope this is informative and helpful for you. If you have any question, you can ask your question in the comment section, and I'll try my level best to get back to you. So I thank you very much for watching this video. If you haven't yet subscribed to this channel, kindly do so, and click on the bell icon so that you can get timely notification about my other videos. Thank you.